Let's go through the Factorial Designs worksheets. Um, this experiment had two independent variables, type of music and temperature. Those were IV1 and IV2. The two levels of type of music were classical and silence. The two levels of temperature were 60 and 80 over here. The dependent variable was recall because each of these numbers that I'm recording in here, each of these 8 numbers was a recall score. What I did was I calculated the average of each of these boxes. So what I did was I got the average of 8 and 10, which is 9. The average of 5 and 7 is 6. The average here is 7, and the average here is 4. I didn't have to add them and divide by 2 because whenever you have two numbers, the mean is the number that's halfway between. So we had a shortcut we could use to get the mean right here. And if we did do the math, we would just do 10 plus 8 is 18. 18 divided by 2 is 9. So these 4 numbers in here are called the cell means because each box is a cell. These means down here, the column means, and over here the row means, are called marginal means. What this mean right here is the mean of all 4 numbers in column 1, the mean of 8, 10, 6, and 8. If you add those 4 numbers and divide by 4, you get 8. Over here, if you add these 4 numbers, 5, 7, 3, 5, and divide by 4, you get 5. This mean over here is the mean of all 4 numbers in row 1. It's the mean of 8, 10, 5, and 7. This number right here is the mean of the 4 numbers in row 2. It's the mean of 6, 8, 3, 5. And this says, is there a main effective type of music? To be able to know if there's a main effect of music, you have to compare the mean of all 4 people in the classical column, which is 8, and the mean of all 4 people in the silence column, which is 5. If the mean of the classical condition and the mean of the silence condition are not the same, then there is a main effective type of music. And we can see that 8 and 5 are different. They're not the same number. So yes, there was a main effective type of music. Classical music did do better than silence. Is there a main effective temperature? To find out, we have to compare the mean of all 4 people who were in a 60-degree room and the mean of all 4 people in the 80-degree room and see if they're the same number. They're not the same number. So yes, there is a main effective temperature because the mean at 60 degrees was higher than the mean at 80 degrees. The 4 people who were in a 60-degree room did better than the 4 people who were in the 80-degree room. So yes, there was a main effective temperature. Now, if these 2 numbers down here had come out to the same number, if they had been 5 and 5, there would have been no main effect of music. And if these 2 numbers had been the same, for example, if they had been 7.5 and 7.5, there would have been no main effective temperature. Is there an interaction? To find out if there's an interaction, we have to plot the cell means in a graph. If you wanted to just use the table, what you would do is you would look at how far apart these 2 numbers are in row 1, and you would look at how far apart these 2 numbers are in row 2. If the difference between the 2 numbers in row 1 is not the same as the difference between the 2 numbers in row 2, then that would be an interaction. Now let's take a look at these numbers. 9 and 6 are 3 apart. 7 and 4 are also 3 apart. So the difference in row 1 is 3, and the difference in row 2 is 3. Since they're the same difference, there's no interaction. And if we plot them in a graph right here, we can see that at 60 degrees right here, the averages for silence and classical are 6 and 9. That's just right here. 6 up to 9. In the 80-degree room, right here, the numbers are 4 and 7. So 4 for silence, 7 for classical. This line goes up by 3. This line also goes up by 3. So the lines end up being parallel, and there's no interaction. So there's no interaction right here, and the result is showing that the effective type of music does not depend on temperature, because if it's a 60-degree room, classical is 3 higher than silence. If it's an 80-degree room, classical is still 3 higher than silence. So the effect of type of music is a 3-point difference at both temperatures. So no, the effective type of music does not depend on temperature in this data set right here. Now let's take a look at the next one. Here we have a different result. I just did these calculations over again with these new numbers. The two column means are different for classical and silence, so there is a main effect of type of music. The two row means for 60 and 80 degrees are different right here, so there is a main effect of temperature. And in the first row, we have a difference of 3, because the difference between 6 and 9 is 3. And in row 2, the difference is only 1, because the difference between 4 and 5 is only 1. So since the difference is not the same in the two rows, there is an interaction. So if we plot them in a graph, we can see that it's not parallel. And since it's not parallel, there is an interaction. It's a yes. So at 60 degrees, in the 60-degree room, classical is 3 higher than silence, because it goes up from 6 to 9. But in the 80-degree room, classical is only 1 higher than silence. It only goes up by 1. So the line is not as steep. It's steeper here and not as steep here, which makes them not parallel, and there is an interaction. So remember, parallel lines means no interaction. Non-parallel lines means there is an interaction. And what is this interaction showing? Well, it's showing that the effect of the classical music is steeper when it's 60 degrees and not as steep when it's 80 degrees. So it looks like classical music improves recall more when it's 60 degrees and not as much when it's 80 degrees. Does this result seem to be showing that the effect of type of music depends on temperature? Yes, because when it's 60 degrees, the difference from silence to classical is 3. But when it's 80 degrees, the difference from silence to classical is only 1. So the effect of type of music does depend on temperature in this data set. It's a bigger effect at 60 degrees and a smaller effect at 80 degrees. So it does depend on temperature. Here, I did everything over again. These two means are equal, so there's no main effect of type of music. These two means are equal, there's no main effect of temperature. But look what we have right here. When we go from 6 up to 9, so what you might be thinking right now is, if you go from 6 up to 9, that's a difference of 3. And when you go from 6 up to 9, that's also a difference of 3. But so we have a 3-point difference in both rows. But the thing is that the difference we have here is the opposite of the difference we have here. Here, When you go from silence to classical, you go up by 3. You go from 6 up to 9. But in row 2, you go from 9 down to 6. You go down by 3 when you go to classical music. So when you graph the lines right here, you see an X like this, because in the 80-degree row, which is this line right here is the 80-degree line, you have a recall score, an average recall score of 6 for classical, and an average recall of 9 for silence, like this. But when it's 60 degrees, which is this line right here, you have an average recall of 9 for classical and an average recall of 6 for silence. So it's an opposite. They're the opposite of each other. And when that happens, there is an interaction. The lines are not parallel, so there is an interaction. So what this interaction seems to be showing is that classical music improves recall when it's a 60-degree room, because in a 60-degree room, recall is at 6 at silence and goes up to 9 at classical. It shoots up like this. But when it's 80 degrees, in the silence room, when there's silence, the recall is at 9. But when you go to classical, it drops down to 6. So classical improves recall at 60 degrees, but lowers recall at 80 degrees. Classical the music has an opposite effect at the two temperatures. So this result seems to be showing that the effective type of music depends on temperature. Yes. Because there is an interaction. Here we have a 2 by 3 design, 2 temperatures and 3 types of music. And I just filled all of those in right here. To find out if there's a main effective type of music, you have to compare the 3 averages for the 3 columns. If they all come out to the same number, like 7.5, 7.5, and 7.5, then that would be no main effective type of music. But if at least one number is different than the others, there is a main effective type of music. So these 3 numbers are all different from each other, which means that there is a main effect type of music. And if it had been 7.5, 5.5, 5.5, that still would have been a main effective temperature, because we still would have had a difference in here somewhere. These 2 numbers, the 2 temperature averages, the 2 recall averages right here for 60 and 80 degrees are different, so there is a main effective temperature. Is there an interaction? Well, when you plot these cell means, so in the first row it's 5, 7, 9. In the other row it's 2, 4, 6. They end up being parallel, which means there's no interaction. What about this right here? Well, let's look at the main effects first. We have 6, 4.5, and 4.5. These means are not all the same, because 6 is different than 4.5, so there is a main effective type of music. These 2 numbers are different, so there is a main effective temperature. And when we graph the cell means, we have 3, 3, 3 for the 80-degree row, and 6, 6, 9 for the 60-degree row. They are not parallel, so there is an interaction. And what does this interaction look like? Well, it looks like when it's 60 degrees, people do better at the recall task with classical music up here, and they do worse with both jazz and rock. But when it's 80 degrees, people do equally poorly with all three types of music. So classical music leads to better recall than rock or jazz when it's 60 degrees, because 9 is higher than 6 and 6. But that's not true when it's 80 degrees, because when it's 80 degrees, the recall average is 3, regardless of what type of music you're listening to. So it's answer B. And the effect of type music does depend on temperature, because classical music leads to better performance than jazz or rock, but only when it's 60 degrees. If it's 80 degrees, that's not true anymore. So the effect of the music does depend on temperature in this data set. Let's look at another one. But first, I said that there is an interaction because the lines are not parallel. Here the line stays flat all the way across, and here it has a jump in it. So they're not, the two lines are not parallel. So there is an interaction. Let's look at this one right here. Well, is there a main effective type of music? We have 7.5, 4.5, and 4.5. So 7.5 is different than 4.5. So since these three numbers are not all equal to each other, there is a main effective type of music. Since 4 and 7 are different, there's a main effective temperature. But when we graph the lines, in the top row we have 6, 6, and 9 right here. And in the bottom row we have 3, 3, and 6, like this. And these two lines end up being parallel because the shape of this line is exactly the same as the shape of this line. So the two lines are exactly the same, which means that there's no interaction. And the effect of music does not depend on temperature in this case. Let's now look at the three-way interaction. So we had a 2x2 design and a 2x3 design. Now we have a 2x2x2 design. So I filled in all of these cell means for all 8 boxes. And we have 2 different types of music, 2 different temperatures. We also have 2 different types of availability of water, which basically means that these 8 people over here did not have any water during the experiment, and these 8 people over here were allowed to drink water during the experiment. I just filled in these numbers. And it's asking what types of results were found. The first 3 right here, we're asking about the main effects of the 3 independent variables. The main effect of type music, the main effect of temperature, and the main effect of availability of water. To find out if there were any main effects, we have to do some, you have to calculate some averages, and I'll show you how we did that work. This is what we did for the main effects. So I took the 8 for the main effect of type of music, which is classical versus silence. I took the 8 numbers, the 8 recall scores for all of the people who listen to classical music and put them in this column right here. And those recall scores were 8, 10, 5, 7, 8, 10, 5, 7. So these 2 people here, these 2 people here, these 2 people here, and these 2 people right here. Those 8 recall scores are all here. For silence, I took the 8 recall scores from people who listened to silence, which were 5, 7, 4, 6 over here, and 5, 7, 2, 4. Those were the 8 numbers. Then what I did was I calculated the average recall score of all 8 people who listen to classical music. I took these 8 numbers and added them and divided by 8, and I got this average. I took the 8 recall scores for all people who listen to silence. I added them and divided by 8, and I got the average for the silence condition. And what I do now is I look at these two averages. If they come out to the same number, there's no main effective type of music. If they come out to different numbers, there is a main effective type of music. So since they came out to different numbers, there was a main effective type of music in this data set. Over here, I looked at the main effective temperature. What I did was I took the 8 recall scores for all people who listened to for all people who were in the 60-degree room. And how did I get those? Well, this is 60 degrees. Those 8 recall scores were 8, 10, 5, 7, 8, 10, 5, 7. All of the 8 recall scores in this top row right here were in the 60-degree condition. So, like I said, 8, 10, 5, 7, 8, 10, 5, 7. I put those right here. I took the 8 recall scores for people who were in the 80-degree room right here. Those recall scores were 5, 7, 4, 6, 5, 7, 2, 4. Basically everything from this bottom row down here. I got the average of this column and the average of this column, and they're not the same number. So there was a main effective temperature. To look at the main effective availability of water, I took the 8 recall scores for people who did not have any water, which were all of the recall scores over here. 8, 10, 5, 7, 5, 7, 4, 6. Everything in this grid right here, I put in this column. This says water is available. For this column, I just took the 8 recall scores from people who did have water during the experiment, which were all of the numbers in this grid over here. 8, 10, 5, 7, 5, 7, 2, 4. Those went into the available column. I took the average of these 8 people and the average of these 8 people, and the two averages are not the same, so there was a main effective availability of water. So since we found a difference all 3 times, we had 3 main effects. We had a main effect here, a main effect here, and a main effect here. So we had a main effect of all 3 independent variables. Now what I asked for over here was the interactions between pairs of independent variables, interactions between 2 independent variables. And I'll show you what I mean. We wanted to look for an interaction between type of music and temperature, an interaction between type of music and availability of water, and an interaction between temperature and availability of water. So an interaction between IV1 and IV2, an interaction between IV1 and IV3, and an interaction between IV2 and IV3. I'll show you how we can find out which of these were in our data set. Find out whether there was an interaction between type of music and temperature. We have to combine everything back down into a 2x2 design, in which the columns are the types of music and the rows are the temperatures, like they are here. And the third independent variable of availability of water is just being ignored. So what we have here is, right here is the average of all 4 numbers. When you add 8 plus 10 plus 8 plus 10 and divide the total by 4, you get 9. When you add 5 plus 7 plus 5 plus 7 and divide the total by 4, you get 6. The same thing down here. This number is the average of all 4 numbers, and this number right here is the average of all 4 numbers. So each cell mean is an average of 4 numbers, not just 2 numbers. And when we plot in a line graph right here, in the top row it goes from 6 to 9. This is 6 to 9. This is 60 degrees. In the bottom row, it goes from 4 to 6, which is right here. This is 80 degrees. And the two lines are not parallel because this goes up by 3, this goes up by 2. So this is steeper than this. So there is an interaction between music, type of music, and temperature. Now we want to look at whether there's an interaction between type of music and availability of water. We just get the cell means over again. This time the columns are the types of music, and the rows are availability of water. And temperature is ignored. So when we plot these four cell means, what we have is, in the top row, it goes from 4.5 up to 7.5, this line right here. In the bottom row, it goes from 5.5 up to 7.5, which is this line right here. And this line goes up by 2, from 5.5 to 7.5. This line goes up by 3, from 4.5 to 7.5. So the two lines are not parallel, and there is an interaction. So we have an interaction between type music and temperature. We have an interaction between type of music and availability of water. Now we have to look at whether there's an interaction between temperature and availability of water. And when we plot it, when we plot these four cell means, we do have an interaction right here. I have the types of music down here. I'm sorry. We're ignoring type of music in this sheet right here because we're looking at music and water, and we're ignoring music in this case. So we're plotting these four cell means. Right here, when water is available, we go from 4.5 to 7.5, which is this line right here. When water is not available, we go from 5.5 to 7.5, which is this line right here. And one line is steeper than the other line because this is a 2-point difference, this is a 3-point difference. So there is an interaction between temperature and availability of water. So we found all three of those interactions. So we found all three main effects. We found all three interactions. So these are all check marked. The last thing we have to check for is a three-way interaction. To be able to find out if there's a three-way interaction, you have to break things back down into a 2 by 2 by 2 design, which means we go back to this type of diagram right here where we have 8 boxes. Then what we do is we make a graph for these 4 boxes over here for when water is not available. And we make a same type of line graph for these 4 boxes when water is available. If this graph is not the same as this graph over here, then we have a three-way interaction. So let's take a look. Over here we have an interaction because the lines are not parallel. And over here we don't have an interaction because the lines are parallel. So we have an interaction in one graph but no interaction in the other graph. That's a three-way interaction. So we do have a three-way interaction. If they had both been parallel, that would have been no three-way interaction. And if they had both looked like this over here, then that would have also been no three-way interaction. The fact that they're different from each other is what gives us a three-way interaction. So we have a three-way interaction. So we're going to check this box right here. So we checked all of these. We found all of them. And then Now it says, how would you describe the three-way interaction? We have to find out which of these is correct. Well, let's take a look at the graph. What it looks like is when people do have, when people don't have any water during the experiment, then the hot temperature of 80 degrees makes them dehydrated. And because of that, the classical music no longer helps them. It doesn't help them as much because when it's hot, recall only goes up by 1 when you have classical music instead of going up by 3. But it looks like when they do have water during the experiment, the hot temperature doesn't affect them anymore because of that, when it's 80 degrees, their recall goes up by 3. It goes up just as much as it would if the room had been colder. So when it's hot and you're getting dehydrated, classical music doesn't help you as much. When it's hot and you have water, classical music does still help you just as much because the water is helping you deal with the temperature. Because you have water, the hot temperature isn't affecting you anymore. So let's take a look at what answer that would be. If water is not available, which is over here, classical music has less of an effect when the temperature is hot, because when water is not available and it's hot, it's 80 degrees. When you have both of these two things together, the difference only goes down. The difference goes down to a 1-point difference, where classical music only helps you by 1 instead of by 3. So if water is not available, the effect of classical music becomes weaker when it's 80 degrees. But if water is available, the effect of the music is just as strong at both temperatures. It's a 3-point difference regardless of what temperature you have. So when water is not available, classical music has less of an effect when the temperature is hot at 80 degrees. So the results are showing that the interaction between music and temperature depends on water, because the reason why it's yes is because we have an interaction over here and no interaction over here. So the interaction does depend on whether water is available or not available. The interaction does depend on IV3. Let's go back to that page. The answer is yes for number 4.